Okay, cool. We're back Friday morning after Halloween. Hopefully it was a good night. I guess we still have one more minute. That's okay. Hopefully a good night. Get some sleep. And we are into module 4. This is our last module that's required for the semester. And then module 5 is a little bit of a mix of what we were doing with initial value problem, like differential equations, and then also linear algebra, some work, but kind of tying those things together. So if you like this, you want to keep going and keep seeing where this goes, and that's a good next step to take is module 5. But first, getting through module 4. How's it going? Good? Making progress? Okay. Anything weird or interesting happen? Errors? Are you getting errors? There should be a yes, but I don't know.
Only for the first one that asked if you're getting it.
Yeah, yeah, and that first homework problem, right?
Yeah.
There's no way to solve this problem. At least not with a computer. Like as a human, I can look at it and say like, oh well, x5 is the same as x1, just negative. Like have a symmetry plane in x3 or something. Say that x5 doesn't move, the rest of them do move. But for a computer, just telling it like, okay, here's everything, you have to get an error because there's an infinite number of ways that we can satisfy that equation. Yeah, so if I set it up, I use like this fancy, not super fancy, but like since this matrix has a lot of symmetry in it, I can set up like the diagonal of the matrix and then the off diagonal parts. So like 1 is going to give me the top, like all these negative k1, 2, 3 up top, and then that negative 1 over here will give me all the stuff down here, that negative k2, k3, k1, 2, and 3. And then just set the first and last values. And sure enough, when I create these two arrays, one is a 5 by 5, another one is a vector with 5 inputs, I get this big error saying like, hey, you can't do that. Yeah, I feel like it gives you too many details at this point. Singular matrix is like the one detail that you need, but
That's like tracing through every single step in the actual linear algebra function.
Yeah. Yeah, so the way is kind of like work your way backwards. So this is your main output, then it's showing you here in this main, like, so the solve command is part of this linalg pi script, like a whole bunch of functions and classes in there. And it's showing you like, all right, this is the function that raises that error. And then going up one more, it's showing you like, all right, in that solve AB, it's hitting it right here, or GU func AB signature. And then finally it shows you at the top like what you actually inputted. And sometimes the trace goes through a few more functions depending on how deep you get into the matrix. So it is helpful if you're trying to debug. So if I look at like just taking that stiffness matrix K, what does the condition number tell me about it? What is the condition of K? No, that's all right. Something that we're sorry to talk about. That condition of this. Power of what? Oh, it does. So like the number that you're about is like the 60. Like in that sense. Like, the condition is like the formal definition is like max norm of K times the norm of the number. In this case, it's really big. That means one of them is a number. It's like the most impressive thing you can say in something like, this problem's not solved. Have you checked the condition number? So condition number is like definition is like matrices don't really have like a magnitude. It's not like they're not a vector. They don't have like a magnitude and a direction. They're more like almost like 3 magnitudes and 3 directions depending on what shape they are, but like, or I guess how many levels there are to the array. But one way of thinking of kind of generalizing that magnitude idea is the norm. And there's lots of different ways that you can calculate norm, but if you take norm of A and norm of its inverse, that is the condition number. And roughly, that's going to tell you that when you solve a linear algebra problem, the condition number is like how much error there could be in that solution. So if our condition number is 10 to the 16 and we can only store 64-bit floating point numbers with 10 to the negative 16 values, best case scenario is kind of like the answer we get is plus or minus 1. So it's not super helpful. So ideally you want condition numbers that are very low. It's okay if they're like 1,000 or even 10,000, but as they start getting into the 10 to the 16, 10 to the 17, even 10 to the 12, now you're like, it's going to be harder and harder to get an accurate answer based on the limits that we have with how we store numbers in the computer. Because if I just look at everything except for the last row and last column. So setting up case number 2 rather than case number 1, where case 2 has a nice fixed boundary point. There's only going to be one solution to it that satisfies this set of equations. And that one has a nice condition number of 30. I mean, 29, but 10 to the 1 sort of power, not 10 to the 16 power. So much easier to solve that one.
puts that long. It's better for a simple matrices, but
Yeah.
it's still not very consistent.
All right. Maybe we can get.
It might just be a format.
That's what I'm wondering. So we're gonna go big. Try the big one first.
It's pretty consistent for the X matrix on the 1 by yes 6.
Yeah. That's what I'm trying to figure out. Is like if you take the raw LaTeX code and say, hey, I want a NumPy array, will it give it to us? I mean, this looks pretty good, right? That's working pretty well. Yeah, some modern engineering, right?
Yep.
It even gave me A and B for the matrices. Yeah, so we were, yeah, I was just kind of looking through what was going on in the class, and someone was taking this array and kind of like copying it and saying, hey, ChatGPT turn this into a NumPy array? But in the background, you have like, if you can get to the raw code, whether it's HTML or LaTeX or whatever the code happens to be, but if you can get that raw code and give it to ChatGPT, it's really good at taking one table and filling in information into another table. That's one of the best things that ChatGPT is good at doing, like taking your resume and auto-filling a whole bunch of stuff. Sorry, go ahead.
Yeah, I guess the way I was asking it, the formatting was weird, so I started losing it.
Yeah. Let's see. I think so. One thing that it was doing was, I think it was assuming that alpha and beta were certain values. Yeah, it just made up values for them, which is fine, but we can correct it. So I could copy this in. That one's easy, yeah. So pasting this in. So I don't love the way that it's kind of making this B array, just because you don't need to define B as like a whole bunch of bracketed rows like this. Like it doesn't have to be a column vector. It'll work. Like it's fine, and I can always reshape it after the fact. Like,
I mean, whenever I've done it, it's given me a row. So.
So what did we have? We had alpha 75. Beta was 30, so that was kind of a good guess. And then theta is pi over 4. And then F, we'll give it 1,000 newtons. And here, again, I like to, if I'm going to copy paste, improve. And then let's see, 0 sine 0, 1, 1 cosine 0, 0, 1, 0 cosine cosine 0, 0, 0, 0 negative sine, positive sine 0, 0, 0. This looks pretty good. I mean, it copied it over better than I could. I usually make mistakes as I'm trying to like transpose my work. And it gives us values for all the outputs. P1, 2, 3, R1, 2, 3. But here we're supposed to use the Gauss elimination in this step. Which we can find. In that part 2 reading. I already imported NumPy. I don't need these. And what you should find if you plug in these this A matrix and that output B, the naive Gauss is going to give you a whole bunch of nada numbers. So again, like we're doing things to like force the computer to give us an error to kind of see what's the realm of working conditions, like how well does all of this stuff work for us. So naive Gauss elimination is not trying to do any partial pivoting to make sure that it doesn't run into these problems. So we need some kind of pivoting in our solution. And pivoting is whenever you take rows and switch them. Like if I took row 1 and row 2 and swap those places. Technically, I'm also swapping this B, row 1, row 2, but they're both zeros. That was cool. Thanks, ChatGPT. That works pretty well. trying to remember. Oh, you can even right click on it. All right, yeah. So if there's like an equation that you're trying to get in a different format, you can right click and say show math as tech command, or I think mathml. Yeah, mathml will give you like the HTML. So I could give that to ChatGPT too. Convert this HTML table to a NumPy. Yeah, and it does a pretty good job of interpreting that. So whether you use like the HTML or like the actual LaTeX, if you have the code in a nice format, it'll pop it in pretty easy. So that's good to know.
I think as a human doing HTML,
that one's harder. Yeah, LaTeX. Yeah, yeah. The LaTeX, as confusing as LaTeX is, it's a little shorter. Like this is just a tiny little box worth of code versus show as, oh, not that one. MathML. Now it's, yeah, HTML is notoriously difficult to read. There's lots of like, what do they call them? Not pseudo languages, but things that generate HTML for you. Yeah, because it's so hard to write this from scratch. So it's much easier to say like, all right, here it is in a given format. Just turn it into HTML and then show me what it is. Yeah, and that one should work. I wonder if we could do it for a set of equations. So this is only giving me one equation at a time, so I'm going to grab all three. I have three linear equations in LaTeX. Can you create a matrix? No, I want an array A and right hand side vector B for NumPy to solve linear algebra problem. Ooh, look at that. Even identified T1, 2, and 3 as my output vector. Rearrange in the matrix form. What? Look at that. That's pretty good. I didn't know whether or not it would pick up that it had to bring over those Q-ins and the M dot times T-in. And it just did it. Yeah, yeah. So now I even have like the NumPy array. So if you can write out your equations like in LaTeX or any kind of like, LaTeX is good for it's become like the standard for writing equations is LaTeX. And there are LaTeX editor, equation editor now. Yeah, I mean they're about, like this one is about the same as using Microsoft equation editor. So I can highlight stuff and say make that text BF, make this one a text BF. So this one is close to what you see is what you get. Yeah, they're not. It's not super easy to use, but if you can define a set of equations in LaTeX, now with ChatGPT, we can even say like, all right, that's what I'm trying to solve. This is my matrix format of it, and we'll double check that one does this. Is it right? Maybe. It looks right. T1, T2 in the first one. T1, 2, and 3 in the next one. Yeah. I think it did get it right too. That's pretty awesome.
I wonder if you have to specify that it's LaTeX or they ever know.
So if I did not say like, hey, this is in LaTeX, it would probably figure it out based on how much data it has that's already in LaTeX. But the more you can kind of sandbox the answer, the more you get towards something that's actually usable. Where here, like I'm specifically telling it, like I want NumPy to solve a linear algebra problem. So when it creates the answer, it's not just saying like, okay, here's your matrix in another unusable form. Like, no, I want actual usable, I want to plug in values and solve this problem. Oh man, it even guessed that it was temperatures and heats too. That's pretty good. Yeah, it knew that this was like some kind of steady state heat transfer problem. Or like this one's really like thermodynamics, but not bad. The world we live in. Pretty cool.
One from the loss elimination module where they make the error, and I hate that you can see the errors, and I was like, oh, we'll just make it partial.
Yeah. Do partial pivoting, right?
Yeah.
Yep.
And then I worked a while.
Yeah. I need a Gauss elimination. Yeah. Let's see if it does include partial pivoting. Cool. I think it's still helpful to look at naive Gauss because that's sort of.
Yeah, it's helpful to use it and then have it not work and then see what doesn't work.
Yeah. At least if we want to know what the limits to like linear algebra are. It's kind of like we need to be able to flip the equations around a little, and then we need the matrix to not be singular or ill-conditioned. Nice.
Learn something new.
Yeah, you learn some every day. I do like that output. Like, give it 5 equations, 5 unknowns. Tell me what the matrix is.
And like,
Yeah, in both. Yeah, gives it in LaTeX. Gives it a nice like Python script. Not bad.
like before when you pass it in, just from like spread, which is
Yeah.
that's a very helpful.
Pretty good, but better than I thought. Oh, really? Weird. It's the T and it's yeah. This makes sense. Yeah. But that T and that should be. Did you give it one? Yeah. 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 So I think the only like extra thing that I did was saying I told it that I had 3 linear equations and I wanted a numpy like one numpy raised to solve even more. This is going to start like thinking about building things. Yeah, it doesn't have to be transforming. That's the only difference I had. Yeah. So some of at least the stuff that I thought was important of like, okay, ChatGPT, this is what I want you to do. The fact that I'm telling it that that it's linear equations, that's like a big indicator that okay, I want 3 linear equations. So it's not looking for 4 unknowns, like it knows to look for 3 unknowns. And then telling it like, hey, I want specifically an array. Like don't just start giving me like random stuff. Like give it to me in the shape of an array, and then also that right hand side vector b, and then telling it like numpy in particular, because ChatGPT has a lot of training data on numpy already, so it's really familiar with that set of like functions and documentation and all that. Yeah. So if you're trying to recreate this, then some of the prompt engineering that you do need to use is like being as specific as you can, laying out like these are the boundaries that I want you to make answers in.
And those for the issue type of work or the array being a vertical, you could just say, oh, I want B to be a horizontal. I won't.
Yeah, that's true. Right hand side. I could say one dimensional.
One dimensional horizontal. So that just looks better on the code.
Yeah. So let's see if I recreate that. Oh no, now it's giving me that TN again. Just like you got. So someone else got, you were just saying that it was giving you TN. Yeah, it's trying to create 4 equations somehow. No. But I told you 3 equations. But it did make B better. B looks better. So I guess then we'd have to go back and say like, all right, look, T in is a known value. So maybe now it'll figure it out. Taking its time this time around. But that looks better. Now it's back to what it was before. And it put B as a regular, like, one-dimensional array rather than a column vector. Yeah. Yeah. Yeah, me too. When you rearrange the equations, the whole T and like Q and T in your known value. So everything that you know doesn't have code. A T1, a T2, so it's in the right hand side. So there could even be like if you write 3, like another T in but you don't have to use anything here. Just 1. In room 1, all the heat that's going into it is a combination of T and Q. But room 2 and 3 only have Q. Why is that? Yeah. Yeah, because you know the temperature of like the outside air. You know that you're pulling it in some atmosphere. Like, oh, which one? Thanks, Henry. And if we come to an upset, we should also put it on here. But that one's T, so it's in that B1 value. So it's only defining, it's only writing unknowns in that? Exactly. Yeah, your A matrix is only, okay, I see this stuff multiplied by T1 or T2. So each column defines T1, what are the coefficients in each equation? And each row is describing each row. Yeah. That makes more sense. Yeah. Looks like it's working. At least like it seems. I mean, right. Yeah. Okay. I didn't understand why it just used this as yeah. Yeah, that part is a little weird because sometimes it feels a little what's supposed to be there, but it's like everything. Yeah, know it, you know it's over, put it over there. Yeah. Cool. Happy weekend. Sorry. Yeah. I more or less finished homework grade, but I have a question about here, I'll stop this stream and